All right, so before I show you domain and range, and before I talk about domain and range, I need to show you interval notation, because this is the grown-up, nice, mathematically sophisticated way to write domain and range and to write an interval of numbers, and will also be the way you'll be required when you get there. So I'd rather just show you the way to do it now and be done with it, and you'll be pros at it, okay? So when we talk about a range of numbers, I'm going to start you out probably what you did the first time you ever talked about a range of numbers. A number line. Let's say I have a 5 here, and I put this dot on 5, and I drew an arrow this way. Tell me what that means. Yes.
5 or greater.
Greater than 5. And let's say I'm talking about the variable x. So I'm talking about x is greater than y. It's shaded in. That dot is shaded in, so that means it includes 5, right? And the line under the greater than sign means it includes. If I take it the other way, let's say 2 this way. That's just less than, and it does not include 2. Do we all agree? What is, how about this one? Let me show you one more. Let's take those same two numbers, the same circles on them, but this time an in between. Do you remember that? So how do I say that again?
It's like a double.
It is a double. It's a compound.
So it's less than 2 is less than
X.
X is but less than or equal to. Yeah, less than or equal to.
That's combining them both, right? Because look at the way it's facing. That's still saying x is less than 5 because it's going to the left. Less than is to the left. And it's still saying that x is greater than 2 because remember that little alligator mouth you learned about whenever you were really little, you know, it eats the bigger. So x is bigger than 2 and it's going to the right there. Okay, so that's those compound inequalities you talked about. There was also another compound inequality you talked about. Same numbers again, but this time it was an or, that's right. So
Wait. Is that live?
I just, yeah. Sorry. So this would be x is less than 2. Or x is greater than or equal to 5. So those are compound inequalities. So that's all your inequalities. Oh my goodness. All right, so those are all our inequalities, right? All right, we're good to go. So what I'm going to show you is I'm going to show you how to write these a different way. Instead of using inequality signs like this or using a number line, I'm going to show you another way to do it. Before I do that, tell me if something goes on forever and ever and ever and ever and gets really, 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 really big. How do you describe really, 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 really big? Like infinity, right? So I'm going to call this way infinity. And I'm going to call this way, guess what I'm going to call it? Negative infinity. Okay? So you have to get your practice writing infinity signs. Sometimes mine look better than others. That's always what students struggle with. I can't draw an infinity sign. It's just a sideways 8 or it's 2 circles. Yeah, turn your paper to the side and do an 8 or do, yeah, whatever. Just do as best you can. All right, so here's what we're going to do. We're going to do interval notation. Let me set up some things here. If you could describe something as less than or greater than, instead of using those symbols, I'm going to use some parentheses like this. Okay? This will make sense in just a minute. And instead of less than or equal to or greater than or equal to, I'm going to let brackets represent that. So really what I want you to gather from that is parentheses means it does not include the number, and brackets means it does include the number. Does that make sense so far? I mean, I know it doesn't, interval notation doesn't make sense, but does it make sense when I'm telling you use a parenthesis when you would use this, use a bracket when you would use this? Okay? All right. We're going to take that number line. When we do interval notation, we'll have two numbers in this parenthesis. This could be parentheses or brackets, whatever. And we'll have two numbers written inside these parentheses or brackets, always starting with the smallest to the biggest. Okay, it has to go in order, that's the thing. So what we're going to do, we're going to take our number line. Let's do the very first one we did. So what is, on this number line, what is the smallest value that x can take on? 5. Are we all in agreement there? Does it include 5 or not include 5? It includes it. So I'm going to use a bracket. I'm going to do a comma, and it goes up to what? Infinity. Now, we always use parentheses on infinity because you can't actually be infinity, right? So this is this written in interval notation. From 5 to infinity, including 5. It tells you where to start, it tells you where to stop, and it tells you whether or not to include the ends. No.
What about the why is it parentheses?
All right, this means includes. So because it's filled in, it includes. This means does not include. Because you can't actually be infinity. So you would use a parenthesis. Yes. Good question. Let's say I switched it around. Here's my -2, and I'm gonna bubble it in this time. What's the smallest value x can be? Negative infinity. But I can't actually be negative infinity, so I put a parenthesis on it. Up to what? -2. I can be that, so I put a bracket. Let's look at the compound that we did. 2 to 5. We said this was an and, right? It was 2 less than x less than or equal to 5. How could I write that in interval notation? Parenthesis 2. Exactly. Now, there may come times when you have to join more than one set like this together. That might be when I'm talking about an or situation. Remember, because it's got the two pieces with the or in the middle. So let's do that one. Let's say 2, 5, this way, this way. So this is my or situation that I had set up. Was x is less than 2 or x is greater than or equal to 5. So when I set this up in interval notation, what's the smallest that x can be? Negative infinity. Definitely a parenthesis because I can't be negative infinity. It goes up to what? Up to 2, right? And it stops. Do you see that? So I need a parenthesis to stop it and say stop, 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 stop. I can't go past 2. But I do have another piece to add to it. So what I do y'all remember union and intersection? I don't think they teach that anymore. Every time I ask that, used to, everybody was like, yeah. Now, Okay, so we're going to join these with a U. It means union. It combines the two pieces, okay? And it allows me, they're married. Yes, they got married. They're together. And it allows me to add another piece to my interval notation. So now I can pick up and describe the rest of it. So what do I start with? A bracket 5 up to infinity. Does that make sense? Okay, kind of. You'll get plenty of practice with it, don't worry. What if I wanted to describe every single number on the number line? It's got to be an interval notation, though. Yes, yes. This means all real numbers. That means everything. Okay, no restrictions. So are y'all ready to use this for domain and range?
I'm absolutely ready.
I'll give you all a second. Somebody tell me what domain means.
I forgot.
Isn't that what you plug in?
Input.
Okay, so input, that's a way to describe it, what you plug in. What else? Probably heard this word. Independent, because it's what you plug in. Tell me what else domain is.
The dominant.
So if domain is the input or the independent variable, that means that domain is which variable? Which one is that?
Changes the one.
Which is the x. It's the x. Y'all are going way over the top with that. I just wanted you to say the x variable. Okay, so domain is the listing of all possible x values on the graph, okay, or of the function. So if that's domain, then that means range is the y. All possible y values. So let's think about, let's look at a picture. Here's my graph. Let's say, let's just start out with a line. Okay? What is the domain? Of course, an interval notation. What is the domain of that line? In other words, what are all, all possible x values?
-1.
So think about it first. What all can x be?
Negative infinity to infinity.
You're absolutely right. Why?
Because
It's a line. It goes on forever, left to right, right? There are no restrictions on x. X could be anything in the whole wide world, right? Left to right. So the domain is negative infinity to infinity. What about the range? What about the y values? Now I'm talking up and down. Also, negative infinity to infinity. This line is not bounded or restricted in any way. It goes on forever and ever and ever. Right? Left, right, up, down, good to go. No holes, no jumps, no anything. It's just a straight line. Any x, any y is a possibility. We all in agreement? So then, let me change it a little bit.
this is real.
Now I have a parabola. It's a little lopsided. It's not perfectly symmetrical. I do apologize, but you get the picture. If I'm talking about domain, so possible x values, x-axis is left to right. 0. X can be negative or positive. Are there any restrictions on it? In other words, does it not go past any certain point? Or could it be anything? It could be anything, right? Y'all know graphing parabolas, you can plug any x value in and get a y value that goes with it, right? any x. So that means my domain and my range is going to be my hiccup.
I know what
The range is.
Look at the graph, and yes, you're absolutely right. It doesn't go past 0. So what does that mean as far as y values? Remember, smallest to biggest. So what's the smallest y can possibly be?
0.
0. Can it be 0?
Yes.
Sure. Why can it be 0?
It's a real number.
It's sitting on there, so it's included 0 to infinity. Good job, y'all. I just did a really good job teaching. No, I'm just kidding.
You made a scene of inequalities.
I have really eased y'all into this because it's such a... Oh, my Lord. How about this one?
Wait, can I do this on my own? I got you.
Get out of here, guys. Try this one on your own. See if you can do the domain and the range.
So,
What'd you get?
domain. And the range is.
Range is negative infinity to 30.
Good job.
Oh, I did it wrong, but I flipped it.
Always start with the smaller. I'll let you in on a little secret. Domain of all quadratics is negative infinity to infinity. It's always all real numbers. Okay. I made you figure it out first. I made you do a few by yourself.
So everything that we ever do is going to be.
Nah, that's not true.
Quadratic. Every quadratic.
Is a quadratic or like a palagram?
Is it what?
A palagram. A palagram.
Parabola?
Parabola. Avada Kedavra. So, is a quadratic and.
Hold on.
Yeah.
Whoa.
That was a maniacal one.
I looked away for 2 seconds.
Alright, Corbin, what's the big word? That was a maniacal one.
This one I think is easier than the parabolas actually.
Wait, just tell
You just can't, don't look at the circle. Just
What's your domain?
It's negative 2. With a bracket.
It's okay.
Mine's gonna look like an over.
What are all possible x values? The smallest x value that can exist with this graph is negative 2. The biggest x value, then it goes, but then it stops here. So from negative 2 to 2. How about the range? Great job, guys. You know I'm fixing to throw the curveball in here, right? Oh, y'all are so cute.
This is what you do, Jason. Knock things off in my nest.
If you get this one, it's the last one. Yeah.
I just sit behind Joseph and all the time. This.
I have back problems.
Domain and range.
In the back.
I was so glad when he moved because he would put his feet all the way under here.
How about you just do this?
All right, look at it. Look at it before you write it so you're not worried about copying it. Just look at it. Let's do domain and range together. You can copy it while I'm giving you your homework. What's the domain on that graph?
It's the same as on the
It's the same. It's negative infinity to infinity. How about the range?
Oh, there's 2 of them. Yes, there is.
You got to use your or. You're exactly right. So what is it? Union them. That's right. Marry them. Smallest y can be is
Top one is
negative infinity, right? Up to negative 1. Put them together.
And then 3.
Yes. Yes. You definitely won't have anything like this until we get to rational functions. But just to make sure that you